Hello, everyone. This is the video for Chapter 7, Lesson 5 and 6. So today what we're going to look at is combining or adding or subtracting monomials and polynomials. So let's start with monomials. To add or subtract monomials, the terms must be like terms. So just like when we're working with algebraic expressions or equations, we have been working with monomials like 2x plus 3x. We could combine these two because these are what we call like terms. So our definition of monomials is kind of broadening now, where it really includes exponents and things like that. So for instance, you can add like 2x squared times y. This is considered a monomial. You could add this and 7x squared times y. These are like terms. So where they're alike is it's the same variables to the same powers. Okay, so that makes these like terms. You cannot add something like 5x and 5x squared. So just because they both look like they're 5x, because of this power, it now changes these two monomials and makes them unlike terms. So like terms not only have to have the same variables, but they have to have the same powers in the same exact place. So if we wanted to add or subtract monomials, for instance, we have negative 6x to the fourth power plus 11x to the fourth power. Really what we can do is add the coefficients, right? Negative 6 and 11. So I'll kind of break it down and show you we could add negative 6 plus 11. And then the variable part of the monomial is not going to change. So we're going to keep that x to the fourth power the same. And then negative 6 plus 11 would be 5. And so then we'll bring that back with our variables. It's 5x to the fourth power. Okay, so if we want to subtract, we just have this coefficient and this minus 7. So really what we could do is 2 minus 7 and then keep everything else the same, right? And so this would be negative 5 x to the second power, y to the fourth power, and that would be our answer. Okay, so we can line up or group like terms, then add the coefficients. So when we have polynomials where there's multiple things going on, we can actually find the monomials that are alike and add those together. So for example, we've got a polynomial here and a polynomial here. We want to add the two together. So one method is we can use the vertical method. Basically what we're doing is we're lining up vertically the terms that are alike. So I'm going to write this whole first line, and I'm spreading it out a little bit so we can see clearly, but I'm bringing this down here. And then I'm going to line up 14x squared minus 15x plus 9. So I'm going to find where 14x squared is alike. It's alike with a 10x squared. So I'm going to add these, and then I'm going to find where negative 15x or minus 15x is alike, and then plus 9. What I'm going to do is I'm going to look at this vertically. This is going to come down because I'm not adding anything to it. So negative 12x to the third power plus, and this will now become 24x squared. And then now I have negative 4x plus negative 15x, which makes it negative 19x. And then 15 plus 9, which is 24. This is the sum of adding these two polynomials. Okay, what if I'm adding them horizontally? So if I'm looking at this horizontally, I'm going to rewrite everything. And then what I'm going to do is really I'm going to pick apart. So I'm going to take this off. Oh, can't do. Um, so really what I want to do is, let me highlight it. Pick apart the like terms, and I'm going to add those, bring those together. Another set of like terms here, I'm going to bring those together. And then my third set of like terms, I'm going to bring those together. So you can see what I'm going to do here is I'm going to add the 10x plus 10x squared. I'm going to add this 14x squared. And I'm going to kind of bring this together as one step that I'm going to look at. Then I'm going to add negative 4x. I'm look at this as a negative 4x plus a negative 15x as one group. And then I'm going to add 15 plus 9. So I'm going to bring my colors back down. The purples I put together, the blues I put together, and then the yellows I put together. And so I really just, it's almost like I did the same thing with my vertical. I just wrote it horizontally. So now I have negative 12x to the third power plus 10 plus 14, so 24x squared, and then negative 4 plus negative 15, which makes it negative 19. So I'm just going to bring that negative 19x, and that negative becomes my operation, plus 24. And sorry, negative 19x. So this is my answer here. And it's exactly the same as what's above. If I check the two, they're exactly the same. So you can choose whichever method you like better. I personally like the vertical method. I like lining things up. But if you're not used to doing that, then you can do the horizontal method. Okay, subtracting polynomials. So be careful here when we're subtracting things. Remember, subtraction means to add the opposite. So let's kind of break it down into simple terms. Like if I have 2 minus negative 3, remember we've learned that you're adding the opposite. And so when we're subtracting polynomials, we got to keep that in mind. So when you subtract a polynomial, change each of the terms to its opposite. Then add the coefficients. Okay, so look in here. I now have a subtraction symbol. And so if I'm doing this vertical method, I'm lining them up. All my like terms I'm lining up. However, when I'm subtracting, everything here becomes the opposite sign. So if this was a positive, I'm now making this a negative. I'm adding the opposite. So again, I'm adding the opposite. This makes this negative m, and I'm adding the opposite. This becomes positive 12. So I'm doing another addition problem. However, I'm adding the opposite. So when I'm adding the opposite, everything here becomes the opposite. And so now I can do it like a regular addition problem. This would be, oh, I did something wrong here, didn't I? I didn't line up my correct terms. So let's backtrack a bit. We can review this. Okay, so I'm noticing my coefficients are not, let's see, my exponents are not completely the same. So I need to make sure I'm lining up the correct terms. This would be negative 3m to the cubed minus m plus 9. And then here, basically, I have Um, I'm actually gonna do this. I'm gonna add nothing here. 0m to the second power. So now when I add the opposite, I'm going to make this negative 4m to the second, negative m, and positive 12. Everything else stays the same. If you didn't see, this right here was lined up incorrectly. So I got to make sure that when I'm adding it to a term, it's m to the second power. So I just created a term that I could put in place um, of this polynomial so that I could line things up well. Okay, now I have negative 4m to the third power, negative 4m to the second, negative 2m, because negative 1 minus plus negative 1 is negative 2, plus 21. Okay, this should be your answer. Let's talk about the horizontal method. So this might feel a little more familiar to you. I'm going to rewrite everything like what's above, and I'm going to write subtract in parentheses 4m squared plus m minus 12. Okay, so in this case, use a different color here. We've always talked about when you're subtracting something with parentheses to distribute this negative, the subtraction sign, into everything because you're subtracting everything. And so now when I do this, I'm going to bring together my terms, my like terms, and have coefficients, work with my coefficients. So I'm going to bring this down, and I'm going to write this negative minus 4m squared. There's nothing to combine that with, so I'm just going to bring that down. And then I have this negative m minus m, and this 9 plus 12. So this negative made this a positive 12. I'm going to bring everything down and combine what I've worked out. Negative m minus negative m, or sorry, negative m plus negative m. Add the opposite, right? So that's negative 2m, and this will be positive 21. Okay, what if we're multiplying? So for multiplying a monomial and a trinomial, use the distributive property. So when I'm multiplying, this is going to be distributed. And now I have 5n times 3n to the third power plus 5n times negative n squared plus 5n times 8. I'm distributing everything. So when I multiply, I can multiply the coefficients, bring that together, and then think of my variables when I'm multiplying n to the first power times n to the third power. It's going to become n to the fourth power because when I multiply with exponents, I just add, right? And then here, 5n times negative n to the second power makes this negative 5n to the third power, because this n to the first times n to the second makes it n to the third. And then I have 5n times 8 is positive 40n. And that is my answer. So let's talk about solving an equation where there's multiple things going on. When there's parentheses, first step is to distribute. I like to circle my negatives so that I don't forget about them. -5, and here's -1. Okay, so d times d is d squared plus 3d minus d squared plus 4d. Negative d times -4 is positive 4d. 9d minus 15 minus 1. When I look at this, I can see I've got a set of terms I can cancel because I've got a d squared minus d squared. Then I can look at my 3d plus 4d, making it 7d equals 9d. I'm going to work this out, -16 minus 16. Now I'm going to subtract 9d on both sides to combine my like terms. Left with -2d equals -16. Don't forget that this is a -16. Divide by -2 on both sides. D equals 8. And that's our final answer. So it looked a lot more complicated than it really was. Just remember to distribute when you see parentheses. Bring those negatives in with the term, the subtraction sign, make it a negative sign. Don't forget about them. And then just do it step by step. Show your work. All right, that's all I have for today.